and get started, gang. So let's ask ourselves first and foremost the most important question of the day. Let's serve it up. We're going to be talking about systems of equations. So what are they? What are systems? And obviously my big old head's in the way. So let me go ahead and go over her and get my big old head out the way. Man, I'll probably put myself right there. All right. So with that said, hello, everybody. I'm still down here. Basically, a system of equations, everybody. This is what you got to know. A system of equations is exactly what it sounds like. Like, let's break it down real quick. A system, so moving like a bunch of parts, right? System, more than one piece of equations. So basically, a system of equations is just a collection or a group of a bunch of equations. That's it. That is seriously it. Now, the one rule about them is that if it's a system, they're basically using the same parts. So for example, if you have a computer system, an operating system, typically those parts and pieces are going to be working together to achieve a common goal. And that's the same thing here. A system of equations is two or more equations that have the same parts. So the same variables. So typically speaking, this is really the main idea you need to know about systems of equations. Look, we're going to be talking about substitution and elimination and all that good stuff, but none of that matters unless you get this one core fundamental idea down. So this is where I need you guys to really pay attention, because this is it right here. Right here, highlight this. A system is a set of related equations using the same variables. Same variables. Not exactly like a polynomial, Alex. It's literally just like a 2x plus 1 equals 5 or y equals mx plus b. It's simply that. And it's an equation, not a polynomial, because a polynomial is not an equation. It's just a statement. We have two equations. If you notice this, I'm going to zoom in for a moment. I'm going to zoom out. Don't worry about it. Don't worry, guys. Just checking this out here. Look, we have 5x plus y equals 17. We also have y equals 2. Everybody, this is a system of equations, meaning the same variables mean the same thing. So everybody, if this y right here equals 2, what assumption can we make about this y right there? What assumption could we make about that y right there? What assumption could we make? Correct. It also equals 2. It also equals 2. We could plug in 2 for that y right there, and that would work. That's really all there is to it. Like, that's really how one way that we can solve a system of equations, by substituting the value from one equation into the other. All you have to do is do it properly. And, there's plenty of different easy ways to tell if you're doing it properly. But this is really it, everybody. I'm going to say it one more time. In a system of equations, the same variables mean the same thing. And I'm going to write that out for everybody right now. So go ahead and copy this down. In a system of equations, the same variables mean the same thing. So the same variables mean the same thing. There it is. There it is. All right. And so it's also stated right over here. In a system of equations, the same variables represent the same values. That's just another math junky way of saying it. But seriously, that's it right there. If you see a y up here and a y down here, those are the same y. If you see a 2x over here and a 9x over there, the x parts mean the same thing. Everybody, before I even continue, I know I'm being annoying with it, but does it make sense? Yes or no? The same variables mean the same thing when it comes to systems of equations. Perfect. All right, again, that's all you need to know here. The same variables mean the same thing. That's really all it means. So here's what we're going to do, everybody. I'm going to take you through a brief example of how to solve a system. And more importantly, though, what we're doing today is we're going to be learning how to set them up from word problems. So don't worry if I go through this one example and you don't completely, totally understand it. Don't worry, it's not going to be the end of the world, all right? It's not going to be the end of the world. We're going to be all right. So we're going to look at the same exact example here. What we're going to do is we're going to solve this equation or system of equations through substitution. We're going to substitute one value in for another. So one more time, everybody. If we go ahead and zoom in, and I am going to zoom out, don't worry. Actually, I'll keep it zoomed out. But if we just said, hey, look, again, this y equals 2. One more time, everybody. What does that mean? This y equals? What does it mean that y equals? Exactly. It means that that y also equals 2. Also equals 2. And so what we're going to do, everybody, is this. If I were just looking at this equation by itself, 5x plus y equals 17, you can't solve that. You have two different letters. You can't solve that. But if you only had one letter to deal with, you could solve it. And that's why we're going to substitute or plug in 2, because it's going to turn into this. 5x plus the 2 equals 17. So again, all we did was we plugged in y equals 2. That's exactly what we just did. So before I continue, is everyone okay with what I just did? I simply saw that over here it says y equals 2. And so I looked at the directions. Okay, the map says y equals 2. I see a y right there. That y is equal to 2. That's all we're doing. That's all we're doing here. That is all we are doing. This is one of the harder topics, and that's why I have to be really careful about how I express things. And so remember, if you have any questions, please let me know. This is one of those lessons where I'm going to do my absolute best, but this takes, back and forth, asking questions. So here we go. We have the 2 here. We don't really need the parentheses there because it's just a positive 2. So let's go ahead and get to work. Everybody, what's the first step in solving this equation? What are we going to do? Subtract 2. That's incomplete. Subtract 2 from both sides. Subtract 2 from both sides. There we go. Yes, correct. We're going to subtract 2 from both sides. And so what we got next is, okay, we got a cancellation happening right there. And so we're just going to have 5x by itself now. And everybody help me out, man. What's 17 minus 2? What is that going to be? Help me out here. I'm a little slow there. What's going on with that? All right, it's going to be 15. Yeah. 17 minus 2 is 15. And then the last thing that we'll do is what? To both sides, everybody. Complete sentence here. Completely express the thoughts. Just making sure nobody. All right, cool. Yep, we will divide both sides by 5. I believe I have a student. I think they're free students. So let me just, sorry guys, I care about my students. Got to make sure that they have the link if they're eligible. Don't know how they didn't get the link. So, not free student. All right, so let's go ahead, divide both sides by 5, and we are good. That's the last distraction I will tolerate for today. So, goodbye right there. Everybody, 15 divided by 5 is going to give us what? That's going to give us 3. That's right. So, x equals 3. And so, seriously, look, this is essentially like how it pretty much works. With systems of equations, there are 2 main ways to solve them. One of them is called substitution. The other way is called elimination. There's a third method called graphing, but you're not expected to know that on the ASVAB. So graphing, not really necessary. You're just going to need to know substitution, elimination. Christian, I love it when you say easy. I'm going to rock your world later. I got you, man. So with that, let's go ahead and understand word problems in their entirety, though, because this is the bread and butter of today. This is where we're going to make our money. Because if you can set up a system of equations, that means you can set up regular equation word problems. You can probably most likely set up proportions, work problems, distance, rate, time, all of these other problems and arithmetic reasoning, like where you just have to set up an equation that fits the situation. This is where it all really caps off. So if you can master what we're doing today, that really automatically means that you're good in like 6 other topics. Wouldn't that be nice? If you could use this as a confirmation that you're good on everything else. So that's why today we're focusing on this. Tell the story. That's the key to setting up equations here. We have to know how to tell the story. And let me just express what this means. And Anthony, keep your hand up. I'll grab you right there in a second. Okay. Keep your hand up. So, or unless you were raising your hand, like saying, yeah, that would be awesome. If that's the case, then put it back down. You're good. But if you have a question, just keep it there. I got you. So the 3 steps here, again, telling the story. This is my 3 steps to word problem success. It's not going to change. So step 1, you're going to mark or label what you're looking for. Read the question first. You want to know what the question is having you figure out. So I think that for those of us that have been in my program for more than 2 weeks, you know that I'm basically beating this over your head. You know what this is. Read the question. Number 2, though, once you start by understanding what the conclusion of the story needs to be, what information you're looking for, once you know that, hey, now it's time to look at the information that you have. So this is where you look into your tool belt. So the goal is, okay, there's that painting that we need to hammer on into the wall. All right. The information in the problem is your tool belt, what tools you have available to you. That's what this is. And so from the beginning of the story, write out the equation using those keywords. So basically looking for anything that has to do with what you're looking for and start building an equation. And I'll show you how to do that. I got you. But we have to start with the beginning, middle, then end. Start just like that. So once you have step 2 down, once you can build the equation or equations, once you can build them, then that's step 3. That's where you make sure your equation makes sense as a story. I cannot tell you how many times people ignore that step, how many times they go ahead and say, all right, cool. I made an equation. I'm not used to making these, so I'm going to assume that I'm right and I'm going to move forward. Only to find out, everybody, what happens if you're great at calculating, awesome at solving equations, but you're terrible at setting them up? What's going to happen no matter what? What's going to happen no matter what? You're right. You're going to get it wrong no matter what. You're going to fail. You're going to get the wrong answer. It is not just about knowing how to solve as quickly as possible. It's about knowing how to set it up and make sure that the setup makes sense. So that's why I'm really taking my time here. Like, tell the story, tell the story, tell the story. Every single word problem is a story. Know how the story is supposed to end, what you're looking for, then start from the beginning and see where Cinderella goes. All right. So in systems of equations, word problems, you're making 2 equations. You're making 2. That's why it's called a system. Again, more than one. And so before I continue, Anthony, thank you for being patient, boss. Go ahead.
All right. So you said that if you get this down, like the system of equations, then you basically have everything else down, because everything else is basically a story.
Yes. Yeah. So yes, obviously, for sure, because it's a story. But the main reason is because of this. System of equations blends together a ton of different topics. And you're going to find the ingredients of systems of equations in plenty of these AR topics. So for example, let me just take you through. In a system of equations, when you set up both equations, what you're doing is you're practicing translating English into math. When do you do that? Oh yeah, in every single arithmetic reasoning problem. Now, beyond that, what else are you doing? Okay, you set up equations. So with regular solving equations word problems, right there. Distance, rate, time problems, setting up equations, there. Also, when you're looking at proportions, there. Percent word problems, taxes, discounts, there. Like, so basically, if you are using this is the ultimate form of it, because you're not just creating one equation, you're creating 2, and on top of that, you're solving. If you're solving equations, then you're working on math knowledge as well. You're working on solving proportions. You're working on solving percent problems. You're working on solving distance, rate, time problems. So it's all here coming together in this lesson. So let me know if that makes sense, Anthony. I'm going to give you the mic back again.
Yeah, it makes sense. Thank you.
Hey, not a problem, man. Thanks for asking. And so, Mohammed, what's up? And then we're moving on into this first example.
So my question is, you said the story, but I mean, that was only one line. It wasn't a story. Like, it doesn't tell you what's 3x.
Oh, this was not the story. So we're gonna get into the word problems now. Yeah. So that was
just again. You need to stop me, and I'll go ahead. When I go, I just went ahead again.
You're good, man. Hey, you're good. You're always predicting the future here. It's all good. I got you.
Okay.
So let's go ahead here and let's practice telling that story. So what we're gonna do here is we're going to set up these equations. Now, step 1, as a reminder, step 1 is marking or labeling what you're looking for. For the purpose of this example, for the purpose of easing you into this, so that way we can just get our feet wet and not go crazy and not get anxious, I took away that first step. I'm not going to give you what you're looking for, but what I will give you are the two things that we're going to be representing with this equation. And so let me give that to you right here. That way we can see how it works in terms of setting up the story. So we have two things that we're going to be analyzing. One, we have Anderson and Brandon. That's who we're talking about in this problem. And so I'm going to set that up right here. I'll say Anderson's age. It's kind of weird saying my own name, but Anderson's age equals, I'll just say capital A. That's cool with y'all. And then what we have after that is Brandon's age, B. So I'll just say A for Anderson, B for Brandon. Yes or no? Is that okay with everybody before I continue? A for Anderson, B for Brandon. That represents each of their ages, A and B. Nice and easy. So, okay. So remember, everybody, today's goal and purpose is simply to set these equations up. That's all I care about. I'll show you how to solve them, and I'll show you some techniques like using the answer choices to get this done super quick, but that's not the main thing today. So let's go through the story here. Let's go through the first sentence from beginning to end. Anderson and Brandon's combined age is 40 years. Let's break down that sentence nice and smooth. Everybody, it says Anderson and Brandon's combined age. So we're talking about Anderson's age. Everybody, what letter are we using for Anderson's age? Still very weird to say. But what are we using for Anderson's age? A, right? All right, sounds good. Then it says Brandon's age. So what are we using for Brandon? That's going to be B, correct. Then next, it says the word combined. So Anderson and Brandon's combined age. Everybody, what does the key word combined mean in math? What does that typically mean to you? If I say, hey, I got $5 in that bank account, I got $2 in that bank account, what happens if you combine them? You're still sad because $7 still sucks to have. So with that, either way though, we got this down here. We're going to add them together. We're going to combine them. So I'm going to go ahead and grab a different color here. Combined age. So added together. Everybody, the key word is, what does that mean in math? Help me out here. The key word is means what? Equals. And then it says 40 years. And there it is. And so what we can get out of this, everybody, is this. A plus B, Anderson and Brandon's age combined equals 40. Yes or no, everybody? Does that setup make sense? Anderson and Brandon's age combined is 40 years. So if I add A and B, I'll get 40. Again, I'm being very cautious and very careful about how I'm teaching this right now. I can't hit the gas pedal too fast here because I don't want to lose anybody that I don't need to. All right. And that means nobody. I'm not trying to lose anybody. All right. So with that, let's go into the next phrase here, the next sentence. Let's start it off here. Let me just erase this so I can get your full attention. So I'll have Anderson is 16 years older than Brandon. So everyone, let's just capture the attention here. So if I say Anderson, everybody, what number or what letter represents Anderson? Correct. That's going to be A. So let me actually make sure that this is very, very clear by doing this. So first sentence, second sentence. All right, so we have Anderson. Then everybody, what does the word is translate to right over here? What does is translate to? Equals. That is correct, Muhammad there. Yep. It's going to translate to equals, the word equals, or the symbol. And then up there, it says 16 years older than 16 years older than, what does that translate to? what does 16 years older mean? Like, what are we doing to Brandon? If we say that I'm 16 years older than Brandon, that means Brandon, is that adding or subtracting? If I say older, I'm referring to older. Exactly. We're aging Brandon. We're adding to his age. Exactly. And so that means that we'll have Brandon's age plus 16. Yes or no, my party people? Does that second setup make sense? Right over here. Anderson is Brandon's age plus 16. 16 years older than Brandon. If you have a question here asking, can I do 16 plus B instead of B plus 16? Yes, absolutely can. Absolutely can. But this is how these setups are going to work, everybody. Yes, they can get more complicated than this, and I'm doing my best to warm you up to the idea, because I'm telling you right now, once you get this down, that's it. It's a home run, and you're going to be feeling great about this. You're going to be feeling great. So I'm going to give you a couple moments here to go ahead and copy this down while I go ahead and take a question over here. Go ahead. Hey, is that coffee? Your mic is on now. Go ahead. Did you have a question?
No.
Okay, no worries. Boom, muting you. All right, so with that, so there you go. There's your chance to go ahead and copy that down. And I'm going to go ahead and copy this here. I'm going to copy this here. I'm going to bring this back in a moment. So what we're going to do is here. There is an alternate strategy that I'm going to show you to solve this. Because if you look at this here, we are able to substitute the A in here, or we can plug answers in. What I'm going to do is I'm going to show you both methods, okay? I'm going to show you both methods. So allow me here to go ahead and copy this page. And then I'm going to solve it both times. So allow me to grab, there we go, copy it over. So I'll put that there, and I'll put this right over here. I'm going to show you both ways to solve this, and I'm telling you one of these ways you're going to like. So first one is, hey, look, if you're looking at this and you're sitting here like, yo, I don't know how to solve systems. Yeah, maybe you can do an example and make it look easy, but I don't know how to do it. Don't worry. Guess what? On the ASVAB, everybody, true or false, ASVAB is multiple choice. ASVAB is multiple choice. It is true. Yes, it's multiple choice. Also, everybody, true or false? Are we able to use the answer choices to our advantage? We are. We absolutely are. And that's exactly what we're going to do. That's exactly what we're going to do here. So let's get to it. Here's how you're going to plug in using this alternate strategy here. Step one, same deal. You're going to mark or label what the question means, or what the question's asking you to figure out. But you're going to understand, again, that what the question's asking you to find, the answer choices is exactly that. Like, the answer choices represent the answer. And so what you're looking for is right there in the multiple choice section, right there. Step two, you're going to write down how the answer fits into the story. That's the same thing as creating the equations. That's the same thing. How do these answers fit into the story? Oh, Anderson and Brandon are 40 years old combined. So if I add those ages together, that's what I'll get. Okay. So understanding how the story actually flows. And then lastly, step three, you'll plug in every answer until you find the one that perfectly fits. So at first, while you're learning systems, this is faster because the ASVAB is multiple choice. But I do recommend learning both ways, and that's why I am going to teach both ways today. So without wasting any more time, let's go ahead. Let me show you here exactly how we can plug the answers in. So let me say that right here. Plugging answers in. Everyone, in the question, what is the question asking us to find? What is the question asking us to find? Right, Anderson's age, how old Anderson is exactly, everybody, right over here, right over here. That is what the question is asking us to find. How old is Anderson? So everybody, what do these numbers over here represent? What does 12, 27, 28, 32, what does that actually represent? Ages, but whose age? Whose age is that supposed to represent? Exactly. These are Anderson's age. So potential, that's how I want you to mark it down. Potential Anderson's age. Potentially. And why do I say potential, everybody? Let's answer that. Why do I say potential ages for Anderson? Why do I say that? And you can raise your hand if you'd like to. Why do I say potential? That's really the big question here. Revka says it could be. I like that. Anything else here? Why else could you say that? Because there are many possibilities. Exactly. We got 4 options, everybody. How many of these are going to be correct? Of those 4 options, how many of those are going to be correct? Only one. Only one. And that's why we say these are possible outcomes. Only one of them is correct. So here's how we're going to plug and chug, everybody. Here's how we're going to do this. I'm going to grab the 12 right over here. I'm going to grab that 12. And what I'm going to do is I'm going to plug everything in. I'm going to plug everything in and see what works. I'm going to see what works. And so with that said, everybody, watch this. This is how you can really quickly eliminate answers that don't make sense at all. Watch this. If I plug it in, let me tell you right now, if I go over here, if I go right over here, if I plug in 12 for A, and that's supposed to equal Brandon plus 16 years old. Everybody, is it possible to add 16 to an age and get 12? Is that possible? Some people here are saying no. Let me show you why. Everybody, how are we supposed to solve this right here? How are we supposed to solve this? What are we supposed to do? Right, subtract 12 from both sides. Everybody, or not subtract 12. Not subtract 12. Subtract what from both sides? If we want to get B by itself, what do we got to subtract? Yeah, subtract 16. If I subtract 16 from both sides, everybody, what is 12 minus 16? What the heck? That's -4. Everybody, can Brandon be -4? Can we be looking at 4 years before this dude was conceived? If you're planning your baby's names that far ahead, I am telling you right now, I ain't the dude for you. So no, that's not going to work. Does everybody see that? How that just doesn't make sense. If you plugged in 12 for Anderson's age, Anderson's supposed to be 16 years older than Brandon. If Anderson ain't at least 17 years old, this ain't making sense. Or even 16 maybe, but this just ain't making sense. Yes or no, does what I said make sense? Does me saying that this doesn't make sense make sense? Let me know. So this is what I mean by plugging in the answers. Okay, plugging in A equals 12, that ain't gonna work. So we're gonna have to work a little more quickly here to try to plug in another potential answer. So try number 2. What number are we trying now, everybody? We're gonna try the 27 out. We're gonna try the 27 out. Let's try it out here. Again, just try B out. And you don't always need to go in order from least to greatest. You're good. But I'm gonna try 27. So with that said, everybody, if I'm trying 27 out, let's just use the same equation. You can use either one, honestly. You're good. If I said A was B plus 16 and I start plugging things in, let me try it again. So everybody, if A is 27, so if Anderson's age is 27, what are we gonna do here? What do we do to both sides to get B by itself, everybody? What are we supposed to do? Right, remember, solving equations, you have to work backwards. And so here, we work backwards by subtracting 16 from both sides. So if we plug in that answer, we will get Anderson is 27, and we'll receive Brandon is how old? How old's Brandon? Brandon is 11 in this case because 27 minus 16 is 11. Okay, everybody. Question. I want someone to raise their hand here, and I want you to see if you can explain this in a complete sentence. Now that we have Anderson is 27 from the trial and error, and we have Brandon being 11 years old if Anderson's 27, how are we supposed to know if 27 is the correct answer or not? What can we do now? Nice. I got 3 people. I'm going to answer from all 3. So Christian, go first. Go ahead.
You now would add Anderson and Brandon's age together.
And so what will we need to see to know if we're right or wrong?
It should equal 40.
Exactly.
And it only
Exactly
equals
right
38.
there. Exactly. Jose, Muhammad, David, Cameron, Abdel, or not Abdel, Cameron, David, Muhammad, and Jose. Were you guys all going to say the same thing there? If so, lower that hand. If so, lower that hand. So one more time, everybody, what Christian beautifully stated, and I'm sure our gentlemen over here, we're going to say the same thing. We have Brandon as 11, Anderson's 27. If 27 is the answer, then when you add those ages, it's supposed to be 40. Again, follow the story. The story says if I add them together, it's supposed to be 40. Let's find out. Everybody, is 27 plus 11 equal to 40? Is 27 plus 11 equal to 40? No, it is not. Roger, I saw that. I don't think I have some of those today, not all of them, but 38 equals 40. No, that doesn't work. That doesn't work. It's 38. 38 is not 40. Everybody, does that make sense there? B is not the answer either. It does not work. It does not work. It is not the answer. Because again, it doesn't tell the story. There's a plot hole if we plug that in. Everybody familiar with what plot holes are in movies and in shows? Where the story doesn't make sense at some point? Cool. Let's go ahead and plug in C. Plugging in C, we got 28 years old. Let's try that one now. Let's try that one here. So move that out of the way. You do try number 3. Let's say Anderson is 28. Let's try that out. Anderson's 28. Everybody, if I go ahead and take 28 years old here, and I plug that in, and I'm getting bored, right? Oh man, how many times I got to plug in, right? Okay, if I go ahead and plug this in here, everybody, what do I do to both sides? Just like we said earlier, subtract 16 from both sides, doing the same thing. Everybody, what's 28 minus 16? What's that going to be? I want everybody to hit me in the chat box. 28 minus 16, what's that going to be? Yeah, that gets you 12. That gets you 12. And so we'll have 12 right there. That's going to equal B. And so everybody, B equals 12. Brandon's age is 12 if Anderson's age is 28. So if I take 28 plus 12, is that going to be equal to 40? Is that going to be equal to 40? Yes, that will equal 40. That checks out. That checks out. And then C would be your answer in that case. Yes, although I am not 28. I'm not 28. I lied because I don't want y'all to know my age. But look, the thing is, the point of this is, I wanted you to understand that 1, you have the advantage of using trial and error or using the answer choices on the ASVAB. That's 1. Number 2, I want to warn you against how long that takes. How long that just took. So do we understand both of those points there, everybody? Yes, you can use the answer choices to fill in the story, and the answer that fits the story is the one that works. However, trial and error might take a little bit of time unless you are quick with plugging them in. If you're good at plugging them in, then you can have yourself an easier time, for sure. So what I want to do now is I want to show you the beauty of being able to solve them. And again, today is not going to be all about solving, but this is the last true example that I'll solve all the way out. It's the setup that we're going for. Remember that. So let me show you here. Let me just show you how we would solve this. Let me zoom on in. We have A plus B equals 40. And we have another A right over here that is equal to B plus 16. So everybody, if this A equals B plus 16, what does this A equal? If this A over here is B plus 16, what can we say about this A right there? That's the beauty. That's the beauty of it. Exactly. Exactly. With substitution, we know that these are both the same value. They're the same letter. They're the same number, whatever you want to say. They are the same. And so what I can do here, I'm just going to move this over here just to kind of illustrate this. What I can do here is say, hey, I can plug it in. I can plug it in. And what I can get here is B plus 16 plus, and then I'll just literally copy this. Literally, I'll just duplicate it and put it right there. So all I did here, everybody, all I did, let me just be very careful here. Let me be very careful about how I explain this. All I said was, hey, Anderson plus Brandon equal to 40. Okay. Anderson is Brandon plus 16. So Anderson plus Brandon equals 40 is the same thing as saying Brandon plus 16, which is Anderson, Brandon plus 16 plus B equals 40. Brandon plus 16 plus Anderson, or plus Brandon, excuse me, equals 40. So before I continue, one quick check here. Yes or no, does that make sense? I literally repeated this, just replacing Anderson with Brandon plus 16. That's all I did. Now remember, the reason we're doing that is simply because we cannot solve an equation that has two variables. We can't get a number for that. That's why doing it this way, guess what? We can combine like terms and have an easier time because we have a B over here and a B over there. Everybody, a B plus a B equals what? 2B, it's correct. So we have 2B, and then we have that plus 16 equals 40. Everybody, what do we start off by doing to both sides? That's right. We'll subtract 16 from both sides. We will absolutely do that. So here we go. Subtract 16 from both sides. That's going to cancel out on the left. And we'll end up having 2B. Everybody, 40 minus 16 will give us what? And if you need to do it on the side real quick for yourself, hey, there's no shame in that. No shame in that. Carry the 1. So 10 minus 6 is 4. 3 minus 1 is 2. Boom, right there. 2B equals 24. Lastly, what do we do, everybody? Complete sentence. What do we do? What do we do? Divide by 2 on both sides. Correct. So we end up getting B right there by itself, and we end up getting B equals 12. Okay, everybody, is that the correct answer? Is B the answer? Like B equals 12, is that the answer? Why not? I mean, we just solved the system, right? Why isn't 12 the answer? Like, what's going on? Why is 12 not the answer? I thought we solved it. Exactly, Crystal, thank you. Yep, we're looking for Anderson's age in this problem. Right up here, look at that. How old is Anderson, not Brandon? So what can we do? You use the context. And remember, the context says, yo, right over here, remember that Anderson is Brandon's age plus 16. And because Brandon is 12, you can plug that right in, and you'll see that Anderson equals 12 plus 16. Everybody, 12 plus 16 equals what? 28. And that would be the correct answer. 28, exactly what we got earlier. So just want to take a pause for a moment because I know that was definitely quite a bit, right? Definitely quite a bit. So I do want to just do a quick vibe check real quick to see what's up. Who here likes the plug and chug method using the answer choices? Who here prefers to actually solve it? Which ways do you prefer? I'm sorry, Joseph. Or was that Joseph? Yeah, that's right, Joseph. Exactly. We're using the context to know that we're solving for my age. Exactly. So you like answer choices, solving. Solving is better for you. Both methods are great. Answer choices, solving, plugging them in. So look at that. Again, there we go. So again, people have preference here. And I want you to know what choices you can make on the ASVAB to make your life so much easier here. So with that said, Mohammed, go ahead. What is your question?
Actually, it's not a question. It's the third method to solve it.
Oh, elimination? Not going to go over that right now. That's not what today's class is about.
No eliminations. Like we have two equations. Is that what we call them, elimination?
Yeah, when you add them or subtract them together.
Oh, okay. Disregard that.
That's what we're doing today. Yeah.
Disregard that.
All the problems are going to be solved with substitution today. I'm setting them up that way. I do have a couple of recordings on elimination that I can send over to you if you want me to send them over.
Appreciate it. Take it.
Yeah. So with that, everybody, that's the idea here. You are able to plug and chug as long as you understand the story. You can also set up and solve if you understand the story. No matter what method you use, if you don't understand the story, it's not going to be solvable as quickly as you might think. And so I'll take Monique's question, proudly here. Go ahead, and then we'll move forward from there.
My question is, so with the second way of solving it, so I know how you said basically how we got rid of the ASVAB first, because I know you said basically two variables will never work out. So say we have like a different question and it has two different variables as well. So it's gonna work either way in solving it.
Yep. There's elimination versus substitution in terms of the method you can use to solve. But no matter what, one of those two ways always works, no matter what.
Okay.
And it's really, again, just about how you set it up. Yeah.
Okay, thank you. Well, actually, you should, like, this is a better way for me, so it actually helps.
So I got you back, girl. I got you. Thanks for coming in today. So with that, let's go ahead. Yeah, no worries. So let's go ahead and take a look at another example here. So what I want to do here is I want to give you guys a minute and a half. I want to, just test you a little bit here and give you a little time to try this out. But all I'm looking for here is the setup. I'm going to give my timer here a minute and a half. I'm going to make myself disappear. I ain't even going to be in the screen and I'm even going to be in the frame. So let me go ahead and put my face out of the way. So go ahead, timer starting right now. Take a minute and a half and try to set up both equations. Go. Right over here, we're going to focus first on what's the question. Okay, what are both numbers? What are the numbers? Okay, cool. So we're looking at all this right here. Those are the numbers. Okay, great. Let's go ahead and take a look at the first sentence now. So in the first sentence, what do we see? We see that the sum of two numbers is 64. And the difference is 8. So those are essentially two statements in one. We have one saying, hey, the sum of these two numbers is 64, and the difference of those numbers is 8. So with that said, here's what I'm going to do. For this first one, let me just keep it the same color. Actually, I'll just do blue just to kind of be consistent with what I'm about to do. And then the second one, I'll do it in green. Okay. So everybody give me some letters. Let's not use A and B because we already did that for Anderson and Brandon. What do we want to use? I think someone used D and F. All right, screw it. I'll just use D and F. It's fine. I'll use D and F. It doesn't really matter, everybody. It really doesn't matter. So if we have the sum of two numbers is 64, doesn't that mean that if I add those numbers together, it should equal 64? Is that what I should be seeing, everybody? Isn't that what I should be seeing? If I add those two numbers together, I should get 64. Okay, sounds good. Now, doesn't that also mean that if I'm looking at the difference being 8, doesn't that also mean that if I do D minus F, that should be 8? If I subtract them? Yeah, that's right there. So does anybody here who was unable to get the setup done, by virtue of anxiety or just, kind of just wanted to see how things flow? Does that make a little more sense to you now in terms of the setup? I really, honest look here. I want to know if that makes a little more sense. Oh, no. Okay. So that's a good point. That helps me understand why we struggled there. Yeah. The word difference does not mean divide. Difference is actually subtract. So basically, if I say like, I got $10 and Crystal has, let's say $15. The difference between our money is $5 because I got 10, she has 15. The difference is 5. You subtract. So just making sure, no worries, just making sure you're good there. So with that said, again, in that first sentence in blue, the sum of two numbers is 64, right there. The difference is 8, right there. And so boom, we've got both of these equations set up. No matter what, again, you need to know how to set it up. Now from here, you got a choice. You can either grab these answer choices and plug them in, or you can truly solve this. Either way is going to work. What's up, Taylor? But either way is going to work. So here's a strategy you can use to plug in. Here's a strategy you can use to plug in. Everybody, which of these answers choices do not have a difference of 8? Which of these for sure do not have a difference of 8? Because again, it says you subtract them, you should get 8. Which of these absolutely will not work for 8? Exactly. C won't work at all. C does not work. C does not work. C does not work. 56 and 8 do not have a difference of 8. So no, that wouldn't work automatically. Then, okay, so the rest of these fit the bill for the difference being 8. Then all you got to do is ask yourself what? Which of these pairs does what now? What's all you got to ask yourself now? Which of these pairs does what? Exactly. Which of these pairs adds to 64? Which of these pairs adds to 64? So let me just go ahead and actually eliminate this with green to show you that it didn't fit the green. So I'm going to use green here for that, and I'll use blue here to represent this one. So everybody, think about it like this. To equal 64, think about the 4. This is a strategy you can use here. To get 4 at the end, doesn't that mean that the first digits of each number have to add up to get 4? Yes or no? Does that not mean that the first digits of each number has to add up to 4 to get 64? The first digits have to add up to 4. And so take a look here. From bottom to top, I'm going to do bottom to top because the answer is going to be A. But let me do it from bottom to top, everybody. Look at this. Yo, does a 0 and an 8, does a 0 and an 8 get you a 4 at the end? If you add them, do you get 64? Nope. You do not. 0 and 8 comes with an 8 at the end. So, nope, not going to work. If I move up over here, everybody, is a 0 and a 2 going to give you 64? Is a 0 and a 2 going to give you a 4 at the end? No, it's not. And if you wanted to know what the exact numbers were, I got you right here. No worries. If you wanted to know what the exact numbers were, they're going to be this. So I'm going to have 30 plus 38. That's going to equal 68. That's why it doesn't work. 40 plus 32, add those together. That's going to be 72. Not going to work. 28 plus 36. Oh, look at that. 8 plus 6 is what again? 14. 4 at the end. Guess what? You add 28 and 36 together. That's going to give you 64. And guess what? A is the answer. Right there. So, does that give anybody a better understanding of how plugging in the answers works? Does that give anybody any sort of sense of peace in terms of how plugging answers in works? Cool. Because again, systems of equations, one of the toughest topics on the ASVAB. But guess what? You have the advantage of the test being multiple choice. Use that to your advantage. One of the answers is there. Plug them in to find out. That's the number one way that you could do it. Yeah, I mean, it's okay. Because the thing, again, look, remember, in the beginning, when you don't know something, yeah, we're overthinking. We're all overthinking. When we don't know something, we're always overthinking. But now it's time to go ahead and kind of, just reframe what we're looking at and how to think about it so we can gain that confidence. So Megan, we got this. That's what showing up is all about. So let me answer a question here from Jose. I got you, Nancy. I will repeat it, but I'm going to solve it the other way next. So go ahead, Jose.
I don't know. You're probably going to answer. You're probably going to explain it. But I was like, then what is the 8 for?
The 8 was the difference. So that was the first thing that we did. We looked at which of these numbers has a difference of 8. Because remember, the difference of 8 means that they're 8 numbers apart. Or if you subtract them, you get 8. That's how we were able to eliminate C so quickly, Jose, because 56 and 8, if you subtract them, you do not get 8. You get like what, 48? That's crazy. These are way too far apart. So that's how we looked at that and we said, yo, this one doesn't work. 30 and 38. Yep, the difference is 8 because you add 8 to 30 to get 38.
Oh, I see now.
There.
The 8 different, yeah.
Yeah, for A, B, and C, it does work for sure, but it didn't work for C. So we eliminated C, and then we looked at A, B, and D, and we said, okay, which one of these adds to 64 now? We proved both parts of the story with this, a difference of 8, and that it adds to 64.
64, yeah. You had to get them different, like 8 times set brackets, you know?
Exactly. So you're just following the story. That's exactly what we're doing here. We're just following the story. Okay, if you add them together, you get 64. Subtract them, you get 8. Find out which pair here does exactly that.
Yeah, because that's the thing that threw me all off, and I was like lost, but now I get it now.
Hey, no worries. Nancy, does that help you out a little more there? Because again, you just need to follow the story here. Which of these pairs of numbers has a difference of 8 when you subtract them and adds to get 64? And we just looked at each individual answer choice to see which one fit the bill. That's all it was. That's how you can use the answer choices. Now, let me show you how to actually solve this. So yeah, we'll get more practice, guys. I got you. Plenty of practice. So what we're going to do here is actually solve this. So solving this, you would actually use elimination to solve this. So I'm actually just going to show you this as a preview, but you could also use substitution, but I'm not going to go all the way through on that. Garrett, I got you in a second. I got you. So what I'm going to do here, in case you didn't know, everybody, you're allowed to add equations together. So let me just make sure that everybody here knows this. Quick detour. Everybody, is it true that 1 + 2 = 3? Is that a true statement? Yes or no? Give me the chat box real quick. Yes or no, is that a true statement? Great. Sounds good. Now, everybody, answer me this. Is 5 + 3, or actually 5 + 2, or 5 plus, I'll do 4. 5 + 4, is 5 + 4 = 9? I'm just trying to use numbers that aren't on both lines. Yeah, 5 + 4 is equal to 9, right? Cool. Sounds good. So if we were to add these equations together, would the resulting equation, like, is what we get still true? Let's find out. Everybody, answer me this. What is 3 + 9? What's that going to be? What is 3 + 9? That's going to be 12, right? Yep, absolutely. All right, sounds good. Okay, everybody, let's go ahead and add 1 + 5. What's 1 + 5 going to be? Help me out. 6, sounds good. Everybody, help me out again. What is 2 + 4 going to be? Okay. Oh, yeah. Okay. 6 again. Everybody, is 6 + 6 12? Yes. 6 + 6 is 12. That works out. That checks out just fine. The point of saying that was just to remind you that if this equation is true and this equation is true, if you add them together, true + true = true. True + true = true. So there it is. This is the elimination method because you are allowed to add these together to solve it. If I added these equations together, watch this, everybody. Everybody, what is 1D plus another D? What do we got here? 2 dimensions, right? 2D. We get 2D. So I'm going to use red for that. Then, everybody, if I have a positive F and a negative F being added together, what happens there? If we have a positive F and a negative F, F minus F, what happens there? That's right, it cancels out. What's another word for canceling in terms of systems of equations? What's another word for canceling in system? Exactly, eliminated. It got eliminated. Exactly. So I'm going to mark that there. Here, F is eliminated. That's why it's called elimination. And then lastly, everybody, what's 64 plus 8? 72. That's right. 72. So what we have right now is literally 2D plus 72. And what we're going to do is do what to both sides? I know I saw that plus there. My bad. We got 2D = 72. But what are we going to do to both sides? Yeah, divide by 2. Divide both sides by 2 for sure. And so when we do that, Boom. There it is. D equals 36. Because if we divide 2 into 72, 2 goes into 6 3 times. Drop the 2, 2 goes into 12 6 times, 36. And so one of the numbers is 36, and you can automatically tell that A would be correct. So you could solve it and still get it done that way. You could still solve it and get it done that way. So with that said, has anybody's perspective or preference changed? Or do you still like plugging and chugging? Or do you prefer to solve the actual equation? What do you prefer? Oh, actually solving. I'm starting to sway you guys. Okay. I'm starting to show you that the big bad systems of equations ain't so bad at all, man. All right. All right. So see some, but it's okay to still say that you use the answer choices. Absolutely okay. Absolutely okay. They both work. I'm telling you, they both work. They both work. And so with that said, Garrett, I'm going to take a question there, boss. I got you. Go ahead. Unless you're raising. Oh, there you go.
All right. Can you hear me?
Sir, how we doing?
I'm doing all right. How you doing? But so I have a question on like, how did you get like two equations in one whole sentence? Like you got D plus F equals 64 and D minus F equals 8. Like it kind of threw me off because what I put in was like N plus 2 equals 64, since it said the sum of two numbers, and I was assuming the 2 was like the numbers. Like it kind of threw me off a little bit.
Yeah, I got you. So before I even answer that question, Garrett, how did you get the link for this class today?
What you say? What you say?
I said, how'd you get the link for today's class?
Oh, through my through my recruiter.
Let me know who your recruiter is, because that shouldn't have happened. Because I just looked at your account. You don't have the all access pass, but I'm gonna just I'm gonna let you stay, no problem. I'm gonna just need you to give me your recruiter's contact info. I gotta talk to them. So
okay,
with that, yeah, no worries. So with that, let me answer your question there. So your question was, you were asking about these two letters, like what are these letters, like where do they come from, kind of thing.
Mm-hmm.
Yeah. So you pick the letters, like you could pick A and B, X, Y. You could pick potatoes and pineapples, bro. It doesn't matter. It's up to you. It's up to you, because it's pretty much you just translating the story that you see up here into actual math. So right here, we saw that, oh, you got the sum of two numbers, but they don't tell you what those numbers are, like X or Y or N, M, K, doesn't matter. It's up to you. And so we just said, okay, Garrett, you know that the sum means that you're adding, right?
Right.
So boom, adding two numbers, 64, right there. You see where that comes from now?
Yeah, I see it.
And then the second one here, the difference, the word difference, keyword in math, means subtraction. And so the difference is 8, boom, subtract, and you get 8 right there.
Oh, okay, I get it now. I get it.
Off from there.
Okay, yeah. I appreciate it.
Hey, not a problem, man. But like I said, go ahead and shoot me a text letting me know who sent you the link.
Okay, I sure will.
All right, appreciate it. So with that said, everybody, what we're gonna do up next is I'm gonna go ahead and show you another problem here. But first, I'm gonna show you how, I'm gonna remind you guys like how we're gonna kind of get through this. And Kevin, I'll answer your question in a moment. I got you. So we got a practice time here. It's about to be 3 minutes per question, and I'm gonna provide some hints. You know, I'm gonna help you along. But remember, everybody, today's goal is to set up the equations, the solution. Yeah, I'll definitely wait to give hints. I'll probably wait like at least halfway through. Oh no, I'm gonna wait at least halfway through. But here's the thing, everybody. You have to make sure you're going through the process the right way. Because if you start deviating, if you try to read the info first before looking at the question, might get stressed out, might feel a little more like, oh crap. You know, you have to make sure you start with the question and make sure you mark it with a variable. Start with the question, mark it with a variable. Then, if something else isn't known, then give it a variable too. Because remember, with systems, you're going to have two things that are not known. So identify the question and then name it with a variable. Then if something else isn't known, which you're going to see that something else isn't known, give that a variable too. And then from there, this is where steps 3 and 4 come in. It's 3 or 4. So either set up the equations and one sentence at a time. Oh, excuse me, right there. I did mess up here. I was like reading this for a moment. So step 3 is going to be set up the equations one at a time, one sentence at a time. And then, excuse me there, that's my fault. Then solve the equations or plug the choices in. So the first 3 steps are going to be the same for everybody. Mark that variable, mark that answer that you're looking for. Mark the other letter if you don't know it either. Then set up the equations, tell the story, and then make a choice. Once you know what the story is, hey, plug these answer choices in, see if they work, or solve it. Up to you. Up to you. All right. Hey, I'm not Superman. You can call me Math Jesus, but Superman now. So with someone called me Math Jesus like 2 weeks ago, and I can't get over it now. But now with that, I forgot I even said that. But yeah, first 3 steps are all the same. It's the 4th step where you have that choice. Everybody, does that make sense there? You have the choice only after you set it up. Let me know if that makes sense. Yes or no. And Kevin, let me know what your question is. But everybody, let me know yes or no in the chat box.
Okay, well, on the last question we did, like, I knew that difference meant like subtracting and like the sum and addition, but I did a way total different way. I think I did it wrong or whatever, but so I did like D plus F equals 64. And then what I did instead was I looked at the answer choices, which I did A first, but I also went through every single last one of them. But I got A first because 36 plus 28 gives 64. And then I did D minus F, which something has to give 8, which is 36. It's just opposite. Just 36 minus 28 gives 8.
Exactly. They didn't put the numbers in any particular order. They just put them from, because you see there's no particular order. This is smaller and bigger, bigger, smaller, bigger, smaller, smaller, bigger. No particular order. The difference being 8 just means that if you subtract them, the difference is 8. Like one number is 8 away from the other. So if you subtract 36 minus 28, you'll get 8. If you do 28 minus 36, you get negative 8. But either way, the difference is 8. When you subtract them, there is a difference of 8.
All right. Thanks, Coach.
Yeah, no worries. So yeah, either way, that works. Yeah. So with that, here's what we're going to do again. 3 minutes per question here. Again, the most important thing here is simply going to be the setup. It is simply going to be the setup. And so 3, 2, and 1. So everybody, first and foremost, in the chat box, go ahead. What are we looking for? Step 1, what's the question? What are we looking for? So even if you were stuck, the first step should not be hard at all. All you have to do is look at the question sentence and point out what it's telling you to find. So what are we trying to find? How old is Trent? Trent's age for Trent. Yes, perfect. And so just to keep things simple, if we're talking about Trent's age, let's use the letter T, right? Let's just go ahead and use T. You could use A, you could use J, you could use Q. I don't know. You could use an Ñ in Spanish. Like, it doesn't matter. It's really up to you. You can use whatever you want. So with that said, we want Trent, and I'm just going to be casual about it. I'm looking for T. Trent's age is T. So I'm hoping no one here, if you were saying that you were stuck on that first step, that tells me that you weren't following the steps. Start with the question. Now, number 2, if I read through the story, just briefly, like I do now, watch this. Together, Trent and Zoe, okay, I know Trent, there's T, yeah. And Zoe, new character, okay, are 39 years old. Zoe, appearing again, is twice as old as Trent. Okay, so here's what happened, everybody. We just related Trent and Zoe in 2 separate sentences. We're looking for Trent. Everybody, do they directly give us Zoe? Do they tell us explicitly, like, yo, this is Zoe right here. She's 5 years old. Do they say that? Yes or no? No, exactly, everybody. If Zoe is not known, then that's called an unknown. That's a variable. Let's put it in there. Let's give it a letter. If we don't know what it is, give it a letter. And so with that said, let's just include Zoe in the story. Everybody, what letter should we use for practical means for Zoe? What letter should we use? Let me just be practical here. Right. Boom. Z. So I'll just use Z for Zoe. But remember, this is what we're looking for. What we're looking for. All right. So now let's tell a story. I see some people asking about what twice means, and I bet you this is where a few of us got stuck, right? So let me help you out here. Let me help you out. So together, let's just focus on one sentence at a time here. Together, Trent and Zoe are 39 years old. Together, everybody, the word together, what does that mean? Add, subtract, multiply, divide, powers, quotient. What is it? Yeah, together. Together, these two people's ages, you're adding their ages together. So what that means for the first sentence, does that not mean this? Does that not mean that Trent plus Zoe equals 39 years old? Is that not the case right there? Trent plus Zoe equals 39. And let me make that a very, 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 very obvious Z so that we don't believe that that's a 2 or something like that. But yeah, it's a Z. Okay, again. So first and foremost, I want to know if anybody was confused on that first step, the addition side of things. Together, Trent and Zoe are 39 years old. Was anybody confused there? Got the first step right, Cameron? There you go. See, that's progress. We can work with that, man, for sure. I know, hey, you're good so far, Crystal. You're good so far. It's the second part that we're going to be making sure that we break down nice and easy for ourselves. So Christian, hold that thought right there. I'm assuming you are going to talk about this right over here. So let me go ahead and get to it. And if you still have that question, I'm more than happy to answer. So let's take a look at sentence number 2 for a moment. Sentence number 2 states, Zoe is. So far right there, everybody, what are we saying? We're saying Z for Zoe. Everybody, the word is means what? Oh, love it. Already blasting it right there. Equals. Z equals. Now, this is where we may have gotten stuck. The word twice. The word twice. So everyone, think about it like this. If I say that I have, let's say I ran 12 miles, okay? So everybody, put your pencils down. Put your pencils down. Let's say I ran 12 miles. Then let's say that my running partner, let's go ahead and say, let's say it's Cameron. So Cameron, what's up, boss? So let's say Cameron is my running partner. I ran 12 miles. Cameron ran twice that many miles. Intuitively speaking, in your head, what number's in your head? What number's in your head when we say twice of 12? 24. Everybody, the word twice means what operation and by what number? What does twice mean? What operation and what number? Times 2, right? Times 2, right there. So right here, Zoe is twice as old as Trent. So that means that Zoe is twice Trent. Double Trent times 2 times 2. Edgar, if you think about it in the opposite sense, so if you're saying, hey, Zoe is twice as old as Trent, then you could reverse it and say that Trent is half as old as Zoe. You could reverse the logic there. Because if you say, hey, Cameron ran twice as many miles as me, I could reverse it and say, yo, I ran half as many miles as Cameron. If you reverse it, so that would be dividing by 2 in that case. But yeah, you can go ahead and flip-flop it. But again, it's about how you read it. Zoe, Z, is equals twice 2 times Trent, T. Z equals 2T. Zoe is twice as old as Trent. Everybody, does that make a little more sense there? When you see the word twice, that's times 2. Long story short, right there. Everybody, when you see the word twice, that means times 2. If you see the word half, that means divide 2. Half means divide 2. Twice means times 2. It's all good. But this is how we have to really work through these issues, right? We've got to work through these issues. This is literally math therapy. That's what we're doing right now. And we're just making sure that our relationship with math doesn't scar us for life. That's all we're doing here. So with that, yeah, Z equals 2T. So with that said, everybody, we have 2 equations set up. The only question is, how are we going to use these to solve? And the thing is, we can use both methods. It's up to us. It's up to us. So I'm going to go ahead and plug in, and then I'm going to go ahead and solve it for real. Either way, they're both quick. They're both quick. So everybody, whose age do these answers represent again? Whose age do these answers represent again? Yeah, these represent Trent. This is why it's important to know the story. These represent Trent's age. And so what do we know about them? We know that, hey, Zoe, you have to take Trent times 2. Whatever Trent's age is, double it to get Zoe. And if you add them together, you get 39. So let's go ahead and quickly go through the answer choices and see which one works. So try number 1. Let me make that red so that way you know that this is like a trial and error kind of thing. So try number 1. Let's say t equals what number? What's the first number there in the answer choices? 7. Let's try Trent equals 7. So everybody, if Trent equals 7, that means Zoe is double Trent. What's 2 times 7? What is that going to be? 14. So then what you're going to do is you're going to ask yourself over here, does it make sense for this? Does it make sense? Can I do 7 plus 14 to get 39? Is that going to work? Is that going to work? If I add their ages, because again, together their ages is 39. 7 plus 14, is that 39? You could carry an extra 1 and that still wouldn't work. No, 7 plus 14 is not 39. And so automatically A, bye. Does everybody see that? Yes or no? Does everybody see that right there? Yes or no? Because Zoe is double Trent's age, if Trent was 7, double that, 14. Okay, so Zoe's 14, Trent's 7. Then the story says, if you add their ages, combine them, you get 39. 14 plus 7 is 21, not 39. And so A wouldn't work. A wouldn't work. So let's go ahead and try B, 13. Let's go ahead and try that out. And you'll go quickly and work quickly and see what you got. See what you got here. 1 second. I love it when this always happens. Right there, just go away. Cool. So let's do try number 2 here. Try number 2. Let's try B equals 13. Let's try it out. So if Trent equals 13 years old, let's go ahead, plug it in. If Trent's 13, Zoe's double that. What's double 13, everybody? What's double 13? 26. We plug them in, so that means Zoe would be 26. So if Zoe is 26 and Trent is 13, supposedly, if we were to go ahead and add them together, their ages together, right over here, add it together, they're 39 years old, add it together, they're 39, plug them in. 13 plus 26 equals 39. Is that true? Is 13 plus 26 39? Yeah, it is. And there it is. B is the answer. B is the answer. So one more time, does anybody see the power of plugging and chugging once you know the story? Do we see the merit behind this? Trent is my son's name. I like this question. Hey, shout out. I'm not going to say your name because that was a direct message, but shout out. Shout out, shout out. Man, I've been on the computer all day. My eyes are burning, especially with these lights. So excuse me if I have to like turn away for a second to clean out my eye. So with that, now we're going to show how to solve this here. I'm going to show you how to set up the solution here. But for the next problems, are you guys okay with, for the final set of problems that we have, that all we do is concern ourselves with the setup and we're not going to go over the solution? I'll tell you, like I'll circle what the right answer is, but I'm just going to basically walk you through the setup for each problem. Is that okay with you guys? All right, cool. Because again, that's what today's about. It's really about the setup. So that's what we're going to do right after I solve this one. The next ones we're just setting up. So Christian, go ahead real quick, and then we'll continue on. What's up, man?
So for some reason, I got it right within the first 10 seconds because
because you're
Z equals,
go ahead.
Z equals 2t. But in my mind, when I'm plugging in Z equals 2t, I'm solving for Z. So when I get the answer, like I got, 2t, boom, t equals 13. Right away, I had the answer. But in my mind, since I plugged in Z, I was solving for Z. So that was Zoe's age.
Yeah, in that case, well, the thing is, you're supposed to solve for Zoe's age as part of the solution because you're supposed to find what fits the bill here. So if Trent's 13, that means Zoe's 26. If you plug that all in together into the first one here, they
Right.
average 9.
So if I were to substitute the Z for the 2T, right there, plug it since Z equals 2T up at the top, the first equation, T plus 2T equals 39. Solve that. That's not solving for Zoe though, right? That would
Oh, no,
be
that is solving. Well, no, that's not solving for Zoe because here's what happens.
right. That's where I'm throwing myself off, is because when I plug in the Z, I'm like, oh, I'm solving for Zoe since I'm plugging in for Z.
Oh, no.
Yes, I'm throwing
I
myself
got you
off
now.
on it. Yeah.
I got you now. So yeah. So here, Z equals 2T. This is also Z. So everything highlighted, they all mean the same thing. Because look,
Right.
Z is 2T.
Okay.
Z is the same exact Z. So if this Z is 2T, that Z is 2T. And so what I can do here, I can just move this over to the side for a second, and I'm going to replace this entire equation. I'm going to duplicate it just to show you guys what's up. I'm going to duplicate it, except I'm going to erase this and plug this in right there. Because again, the Z is 2T.
Right.
Joseph, go ahead and raise your hand, or I'll call on you in a moment here. I got you. But
so when you solve that, you're solving for Trent's age now.
Exactly, because all you see is T there now. So when
okay.
T, that is
because I was second guessing myself, like, damn, wait, I just solved for Zoe. That's Zoe's age. And then I went back and got it. And then that's why I put D, because I freaking messed it up. But now I got it. We're good. We're solid.
Right on, man. Appreciate that. So with that, let's solve this up here. Let's show the 13. And we got this. So the 2T, where it comes from is right here. Remember, with systems of equations, the same letters mean the same thing. So if Z over here is 2T, then you are allowed to change this Z. Again, these Z's are the same Z. If this Z is 2T, you can replace that Z with 2T. And so because of that, boom, now we can solve. Everybody, T plus 2T equals what? What is that going to be? And that's going to equal 39. And so everybody, we divide by 3 on both sides. And what does that give us? Trent equals what? 13. And boom, that's exactly what we were trying to solve for. That's exactly what we wanted to solve for. We got 13 years right there. Boom, full stop, and we're good. So that was the last one that we're going to go through in terms of the total solution, solving it all out. Now, what we're going to do moving forward is we are only going to concern ourselves with the setup. If you can get the answer correct, great, do your thing. I am proud of you, but I only care about the setup. I'm going to give, I know I said 3 minutes before, but I see it's 7:37. And I know that we can at least get one of the equations set up in 2.5 minutes. So I'm just going to deduct 30 seconds. It's not going to make too much of a difference. Trust me. If you can't get it in the first minute and a half, then it's better for me to take the extra 30 seconds to help you than let you suffer. So with that, here we go. 2.5 minutes for these. 3, 2, 1. Let's hit it. All right, sweet. So let's go ahead and go through some of these, some of the setup here. So the setup here, well, we're looking for how much is each item. So what items are we talking about? A jacket and a pair of shorts. So before I even continue, yes or no, are we good on that? The 2 items that are in discussion here is the price of a jacket and the price of a pair of shorts. Yes or no? All right. Muy bueno. All right, sounds good. So let's go ahead then. Let's take what we got and let's go ahead and make some magic happen. Let's make some magic happen. So the first part here is probably what's tripping a lot of people up. But remember, identify the question, shorts jacket, shorts jacket, shorts jacket. That's what we want. So I'm going to say P for the pair of shorts, because I don't want to use S because S looks too much like a 5. So I avoid using S's or O's when it comes to math. So pair of shorts here. And then up next, we have J for the jacket. So I'll just use J for the jacket. All right, cool. Sounds good. So with that said, let's start off with that first sentence. First sentence says a jacket. So I'm going to say J. So everybody, and costs, and that's my fault there. That should say costs with an S. That is totally my fault there. A little error, a little bit of an error. I was trying to get you guys new problems today, so I pumped out a brand new set. Made some mistakes. That's my fault. But I hope that doesn't take anything away from this problem here. Just a minor grammatical error. But look, a jacket. Now, the word costs is the same thing as saying what when it comes to math. If we're talking, if this question is about money, when we say the word this costs, whatever, the word cost means what in math? Equals. Exactly. So think about it like this. Yo, the cost of my groceries was, or my groceries cost $2 for the gummy bears and $5 for the bread. So my groceries cost $2 for the bread and $3 for that. Cost means equals. It's what the end amount would be. And so this is where understanding how to translate English into math really comes into play. The word costs here, since we're talking about money, is equals. And then from there, everyone, this is very straightforward here. 4 times as much as pair of shorts. So what was that going to translate into? That's going to translate into 4 times. Everybody, the word times means what? Word times means multiply. Yeah. So we have 4 times pair of shorts. That would be P. And so we can turn that into J equals J costs 4 times the amount of a pair of shorts. J equals 4P or 4X or whatever you said there, whatever letter you used, but that's how you want to represent it. Does that make a little more sense to anybody who was confused previously? Does that help anybody? Again, picking that word costs, that's the big thing there. I can see where the error may have come from, the confusion, but it's right there. We're talking about money. So when we say that this costs that, we're basically saying this is that. Yeah, no worries. I know a lot of people had it the other way around. I know for sure. But now let's go ahead and look at the other sentence here. The next sentence, I'm going to highlight this in green. Together, everybody, what does together mean? Add. Together, they cost, or what is the word again? Another way of saying cost means what? Equals. That's right. Together, they equal 75. And so, boom, we'll say J for the jacket together with the pair of shorts costs or equals 75. And there is your setup. There is your setup. So that would be the correct setup, and the correct answer would be D. The correct answer would be D if you went ahead and solved. But the setup is all I'm concerned with. The setup is all I'm concerned with. So before we move on, yes or no, does the setup finally make sense for a lot of people here? I love the all caps now. From apprehension to let's go. And so, Mohammed, go ahead with the question, boss, and we'll keep moving forward.
So on this question, what really got me off, the 4, like I had it right, but in my mind, say it like other way around, which is everybody probably most of us are mistake, you know. But so can you explain the first thing, because it got me off? The jacket cost 4 times.
Yeah. So the main idea that we have to grasp here is that since
and also pair of shorts, it just like, I know there's no single short. It's gotta be pair of shorts.
Well,
so that's another thing. Because in one of the, I mean, some questions pair will be 2.
I see where you're coming from. Yeah, okay. I see where you're coming from.
Yeah, I see somebody wrong. Yeah.
Yeah, it's like saying a pair of socks. That'd be different because that's 2 socks, but it comes in a pair. So you're talking about, so that's why I put P for pair of shorts. So you're talking about 1 pair of shorts. And I know the word pair means 2. And that's why, again, if you're asking me, I think English sucks. But again, that's if you're asking me, right? But I'm just the messenger. I am not I'm not the rule maker here.
Yep.
But the word cost, that's really the emphasis here. Because we're talking about money, anytime you see the word cost, means equals. That's the big thing there. So
Right
Jack,
away, I would say J
4 times.
equal 4P, which is what we have the setup. I
Yeah.
don't have to reverse it pretty much, right?
No, you don't.
Okay. Thank you.
And no worries. So here we go, gang. Let's go ahead. And let me lower that hand there, Muhammad. Boom. And boom. Next, 2 minutes for this one. I'm going to do 2 minutes for this one. And then I'm going to see if we can do the next 2 before we head out today. Let's go. Making it hard. Topics easier. 1 problem at a time. Over here. So with that, here's what we got. We're trying to find the bigger number here. So I'll say, A for smaller number, B for bigger. So I'll just say B is the bigger. A, I'll say smaller, since we have 2 numbers. So basically, long story short, we read it and we say, hey, look, the sum of 2 numbers is 45. So the sum of 2 numbers means A plus B, add those numbers, equals is 45. So everybody, before I continue, yes or no, are we good there? Perfect, sounds good. Monique, I'm sorry, holy crap, I just realized I went right over you. Let me finish this and I'm gonna answer you first before I even ask my question. And so there, A plus B equals 45. Then next, one number is 4 times the other. So everybody, which one has to be the one that's by itself? The bigger number or the smaller number? If this number is 4 times bigger than the other, the bigger number has to be the one by itself. The bigger number is 4 times the other number. And so you should have had B or whatever equals 4A. Or in this case, if you had XY, it would have been X plus Y equals 45. And then X equals 4Y or Y equals 4X. Doesn't matter which way you did it. They both would have made sense at the end of the day as long as you solve for the bigger number. Doesn't matter. And so that's your setup, and the answer would have been D if you would have solved it out. I do want to respect you there. Monique, go ahead with your question, and then I'll present mine. Go ahead, Monique.
I really didn't have a question. I had just got booted out for a minute and had to come back in, and I was just wondering what was the answer to that last one since I blanked out and missed it.
Yeah, I got you. It was D.
Thank you. I appreciate it.
Got you. I got you. So with that, the answer there is D. We're going to do one more for sure, gang. I got you. But I got a quick question, everybody. If I were to do another systems of equations class where we're just doing the setups, would you guys prefer that the answer choices were the different setups? Like I put in a bunch of different setups for you to pick from? Would you guys like that instead of the full answer? Just to train you on the setup itself. And I could give you less time because the answer would just be based off of the setup, not actually solving. So we could probably pump through a lot more questions if I just had, this one first, 2x plus y equals 45, or this, and just literally write all the setups. And we could do half and half. Yeah, we could. All right, cool. Just making sure, everybody. Just making sure. All right, next one here. This should probably be the last one here, but it's all good. 2 minutes for this one. 3, 2, 1. There you go. Let's go ahead, try it out here. What are we looking for? How many cross-country skiers are there? So we're looking for what? Cross-country skiers. So that means that all these answers represent cross-country skiers. So basically, I'm going to use C for cross-country skiers. And then if I read the story, one thing I'm going to notice is that there's another unknown. It says the ski club has 47 members. There are 25 more downhill skiers than there are cross-country skiers. So here are my cross-country skiers. And over here, downhill skiers. So I'm going to make sure to label that as well. D is downhill skier. Right there. D equals downhill skier. And so with that said, boom, let's read the story here. Everybody, if the ski club has 47 members, what are they implying? What are they implying here? 47 members means what? In all, exactly, the total. So you have 47 total members. So what that means for equation number 1 is your cross-country skiers plus your downhill skiers is 47. Yes or no? Did everybody get that far there for the setup? Cross-country skiers plus downhill skiers equals 47. Okay, and even if you got to know, that's fine. Now, number two, right over here, there are 25 more downhill skiers than there are cross-country skiers. So everybody, this is where it might feel confusing here. Because if I say, yo, there are 25 more, let's use an easier example. There are 25 more wolves than there are cows. There are 25 more wolves than there are cows. Which one's the greater number, everybody? If I say that there are 25 more wolves than there are cows, which one is bigger? Wolves, exactly. If I say there's 25 more wolves than there are cows, it's wolves that's a bigger number. So flip it here. Same situation. There are 25 more downhill skiers than there are cross-country skiers. Which one's the bigger one? Downhill skiers or cross-country? There are 25 more downhill skiers than there are cross-country skiers. Which one is the bigger one? Downhill skiers, yes. And because of that, right here for this sentence, downhill skiers is 25 more than the cross-country. That's what you would receive in that sense. Because again, downhill skiers, there's 25 more of them than there are cross-country. So you start with D by itself, because that's going to be 25 more than the downhill. Or 25 more than the cross-country. Sorry, I messed that up right at the end. I hope I didn't confuse anybody there. But there's your setup. Thank you guys for staying the minute over. The answer to this question, if we do the math pretty quickly here, we're going to be looking at what? 25. If we do the math, I am blanking out. So that's going to be 2C plus 25, subtract. So you're going to get 22, 11 for cross country. And there it is. We would get A. We would get 11 for the answer.